Well, thanks. Thank you, everyone, for being here this afternoon. I'm Ken Baker with Better Bricks Education and Training, and along with Northwestern Energy out of Montana, Idaho Power Company out of Idaho here, the Integrated Design Lab in Bozeman, Integrated Design Lab in Idaho here, U of I. Thank you for being here. This afternoon, we're going to talk about demand response. Before I get into that, I want to tell you about a few things that are coming up. First thing I got here is the Building Simulation Users Group. You meet the second Wednesday of every month. The next meeting is going to be June 10th, right here, 12 to 1. It's a lunch. So don't forget about that. I know they had a great turnout for that first meeting in April, about 30 folks there. So come, help yourself. For those folks that are watching via the video stream, hi, thank you for tuning in because it's going to be an interesting session. Want to tell you at the bottom of where you're viewing there's an email for Nick who's sitting to my left. And if you have any questions for a speaker or just questions about the program as we're going through, you can email Nick and then we'll get those questions up here to the speaker. So that makes it a little better for you. You can communicate just a little bit that way. I see a flyer back there on the table, Easy Upgrades, the Idaho Power program for existing buildings through July 1st. There's going to be some really great bigger incentives, larger incentives, I don't know how much they are, for lighting. You can go onto their website, idahopower.com/easyupgrades and find out about that, so check that out. Met with a lady this morning from newwest.net out of Montana, for those of you in Missoula or Bozeman in the Montana area, any Billings, Butte, Helena, Montana area. There are some good folks there at newwest.net, and they're bringing a Planning in the West conference to Idaho in June 17th and 18th. And so those of you that are in the room interested in that, pick up a flyer or card which are on the back table. If you haven't signed in, please do that. And everyone on the web, you've had to sign in to get here, so thank you for doing that. Today's session is on demand response. This is the last session of our series for the spring. So glad you're here. We had to cancel last week on Office of the Future. We'll probably bring that to you in the fall. It just wasn't quite ready for prime time yet. So we'll bring that back to you, and I know a lot of folks are interested in that. But demand response is a program that I think you're all going to be interested in. We hear about smart grid now. We hear about demand response a lot. Guy Newsham, who was here a few weeks ago talking about lighting from the NRC in Canada, he talked about demand response programs. So I think it's definitely something that we should all be interested in the field of architecture and engineering, or just buildings in particular. Tonight, Idaho Power is going to start off this presentation. Billie Jo McGuinn, who's right over here to my right, she will begin, and then she'll introduce Michael from Internoc to finish up, to wrap up the presentation. So thank you very much, Billie, for agreeing to be here. We're really looking forward to your presentation and learning about this.
Well, thanks for the opportunity. We think it's a really good one. A good opportunity for us to get the message out about our new program, Commercial Demand Response. Commercial does include industrial and commercial, so we're calling it the Commercial Demand Response Program, but it does include our larger customers as well. And I'm just going to talk real briefly about how we got to where we are with this new program, where we are with this new program, and then I'm going to let Michael do the majority of the speaking. And just to give you an idea, for those of you who I haven't worked with, Billie McGuinn's my name. I'm a commercial program specialist for Idaho Power, and I've been running the Building Efficiency for New Construction Incentive Program for the last 2.5 years for Idaho Power. Previous to that, I was in mechanical engineering consulting for about 6 years. So that's where my background is and where a lot of my emphasis is. But more recently, running the commercial programs at Idaho Power. And then much more recently, I've had the opportunity to help develop this commercial demand response program. So, and I failed to see, now I guess I'll just use this to go forward. Okay. So I'm going to talk real brief and, like I said, turn it over. But what nope, that's not it. What I did want to do, let's try this. No. Technical difficulties. Let's talk about the program development. And Michael will get into more specifics about the program itself. But what Idaho Power has done and how we've approached this program development is we went, okay, we have this residential program, AC Cool Credit, that we've had for a number of years, and we have this irrigation program that we've had for a number of years, and both of which we run in-house. The AC Cool Credit's been a dispatchable program, and more recently the irrigation program this summer, in fact, is becoming dispatchable. But we've had those two markets tapped into for quite some time with the demand response. And the one sector that we haven't tapped into is the commercial industrial. And we knew there was a lot of potential there. We just didn't really know what the program might look like, that we would be able to capture all of the opportunity. And the reason being that when we were looking at the residential program and we said, you know, it's all kind of the same thing. It's all HVAC. So it's similar load profiles for all of our residential customers. When it gets hot, they're going to turn their AC units on. And it's all similar equipment, so we have AC units. So we can put a switch on, the same for all of the residential homes, and cycle their units based on similar load profiles and similar equipment. And it was the same thing for our irrigation customers. We said, you know, what are they all doing? They're watering their fields, and they're all doing that with pumps. And so we have the same type of equipment, we have pumps. And so we can develop a program where we have a switch that we put on the pumps that either turns them off or doesn't allow them to turn on. And they have those similar load profiles. We know that when it's time to water, then the pumps are going to come on, and when it gets really hot, they're going to come on. So to develop a program for our irrigation customers, we develop a switch that either doesn't allow them to come on or turns them off. So it was relatively painless for us to develop these type of programs. And when we started looking at the potential for commercial industrial, we went, wow, you know, it was kind of overwhelming thinking about the variety of energy using equipment as opposed to just AC or as opposed to just pumps. We have, you know, the guy down the street that's an office that just has lights and works, you know, Monday through Friday, lights and AC, 8 to 5, and then we have the guy on the other side of the street that's got a food processing line, and they're running 24/7, and vastly different load profiles and equipment, energy using equipment. So it was very difficult when we're looking at what's the potential out there. What does a program like this look like? So the first thing that Idaho Power did is we started looking at other utilities and what are other utilities doing. And one thing that we found that a lot of utilities were doing is they were utilizing third parties to implement these programs. So we tend to do a lot of the programs ourselves at Idaho Power, but we said, you know, let's look at this. There's maybe a reason why they're doing this. So what Idaho Power did was that in August of last year, we issued an RFP. And unlike maybe some of our other RFPs where it would have said, here's the program that we're going to be implementing, you tell us how much it's going to cost. This RFP said, hey, we're going to be running a program of some sort. If you were to implement that program for us, one, what would it look like? And two, how much would it cost to run? So it gave us a really good opportunity because we were able to take all these different perspectives from different companies and see what the options were for a program for our territory, to see what potential was based on our actual customer data, and then do some really good cost-effective analysis. And the first thing that we found is it's really expensive to run a program if you haven't already invested in the infrastructure. So that's one thing that these third parties that were submitting proposals had, is that they had invested in the infrastructure already. So they were able to implement these programs for us. And from the analysis that we did, we said, yeah, I mean, it definitely makes sense to go with a third party. Before that, we didn't have our minds made up. We wanted to see what was out there. But based on the RFPs that we sent out and the responses that we got back, we said, one, we want to go with a third party. And we did some other research. We went and talked to other utilities that utilized some of them that we had narrowed it down to, and got some really good feedback. And from that, we decided that we would ultimately select Internoc, and that's who's here to talk to you today about the programs. We were very confident in our decision after the feedback that we got from other utilities, after the analysis that we did, very confident in our selection, and that was in November. So from August to November was the selection process. In November, we started working with Internoc to really shape up what this program would look like. So from November until February, this was a long period of time, it seems like, but what we were doing is working out the details of the program. And the two issues at play were, we needed to make this program make sense for Idaho Power to implement because, and we'll talk about why demand response, but the purpose for Idaho Power and what makes this cost effective is we don't want to be building peaker plants. We don't want to have to, every time our peak gets a little bit higher, we don't want to have to build an entire peaker plant to accommodate this small periods of time. And I apologize, I know you're going to be getting into that. But Idaho Power, for this to be cost effective and make sense for us, what we need to do is shave our peaks. So we had a lot of details that we said, how many hours are we going to need to use this to serve that purpose? To be able to prevent or delay the building of peaker plants. How many hours do we need to run it? What months? What are the exact terms? And at the same time, we needed to make it attractive to our customers. So it had to be a program that when our customers are saying, looking at whether they want to sign up, they go, yeah, that makes sense. We can handle that window. We can handle a 2 to 4 hour reduction. We couldn't just say, well, we'll let you know. It could be any day, it could be any amount of hours, it could be any time. So we had to narrow it down in a way that made sense to Idaho Power as well as marketable still to our customers. So that was that period from November till February, and then we felt like we had come to a really good place where we could meet everybody's needs. In February we signed the contract, and in March of this year we filed with the PUC. It happened in that order, and that's part of why now. Well, let me not get ahead of myself. So the PUC accepted a modified procedure, which means that they understood that we're under time constraints and we'll put the customer comment period to a certain period of time. That ended April 15th. So it's gone to decision now. We are here tentatively to be decided within a couple weeks. So we've been there for a while. We've been kind of expecting that ruling. The program has not been approved yet by the PUC. The reason we're talking about it now is, one, we have no reason to believe that it won't be approved. In all of our conversations, we feel like our commercial industrial customers are all for it, the PUC is all for it, and understands that there is a need for a demand response. We're just waiting for the actual approval. And so it's important, given the time frame, considering that, as Michael talked about, the program is June, July, and August, that's a couple weeks away. So it becomes really important for us to do the education piece now, and then we start implementation after we receive the approval. So, and finally, we expect that our first successful events, and when I say events, we mean demand reduction, would take place this summer. So that is program development, where we came from, where we are now, and where we hope to be. And with that, I'm going to let Dina, is that in the other, or these pieces here? Okay. Okay, and if you want to go back to those, Michael, and talk about kind of the program targets at some point. But I just want to open this up for questions before I let Internoc start talking. If there's anything anyone wants to know from a utility perspective or program development perspective, I'd be happy to address that now. Or
what are the customers that will be participating in the program? Is it any sort?
You understand? Okay. Eligibility is any customers with over 200 kW connected demand or billed demand. Of course, it's going to be the larger customers. They would probably be working with first, and then eventually, because it's a 5-year contract, eventually it could get down to as low as 200 kW connected load.
So right now, Schedule 9.
Schedule 9,
and
Schedule 9S, 9P, and 19, but it would probably start in opposite of that, 19, 9P, and 9S.
Does Idaho Power see a threshold where demand response programs would reach their peak between like maybe 100 or so of Internoc and the couple hundred for residential, and then the irrigation side? Is it going to reach a threshold where you say, we really don't need this much more power at all? Or?
You know, that's a really good question. It's actually one that we've talked about, we've discussed internally. We know we're not there yet. So based on the targets that we've laid out for this program, we know that we'll be fine. We need to go after everything that we can at this point. If down the road, because irrigation is a pretty big program, and if down the road we said, you know what, that's more than we need, well then we would start to talk about staging, things like that, about being able to utilize them in a way that's less impactful for our customers. Right now we just need to go after everything that we can. We do know that at this point, but that's a good question, yeah. Okay, anything else? All right, and with that, Michael Rigney is here with Internoc, and I'm going to let you tell what you do as opposed to me trying to. There you go.
Is that good? Good. Good afternoon. Thanks very much for coming out. My name is Michael Rigney. I'm a Senior Director of Business Development with Internoc. So I work directly with our customers and with our sales teams to implement our demand response programs throughout the United States. And I do most of my work in New York and the Mid-Atlantic, Texas, and now Idaho as well. I've been with Internoc since the beginning of 2005. And let me just back up, because I think there were a couple of interesting charts for us to take a look at. Starting with this one, and it kind of goes back to the question around what types of customers will we have. When you add up all these customers, we're going to get a range of megawatts, and the program with us is structured to have a range for where we want to hit. So knowing that we had some uncertainty around the PUC, the lower bound for this year, and the timing around that specifically, the lower bound for this year is just that. It's fairly low, actually. And that's the right thing to do. These regulatory processes, as everyone who has worked in that environment before has seen, they take time. But ultimately, we want to get between 35 and 65 megawatts with a target of 50 megawatts. And so it would be a significant contribution to managing that peak load. Where will that come from? Ultimately, it will come from what Billy said, 200 kilowatts in demand and up. And the amount of load that can be tapped from the relatively small number of very large sites is pretty finite. To get to 65 megawatts, that's going to require putting together a really large portfolio with some customers contributing 100 kilowatts, 150 kilowatts, 200 kilowatts, and some of the larger sites contributing a megawatt, 2 megawatts, 3 megawatts, whatever makes sense for that industrial facility. But it's putting all of those together in one bucket that gives Idaho Power this resource that they don't have right now. And that's where we come in. And if folks want to jump in with questions along the way, that's totally fine. Please.
Out of the, so 35 to 65 megawatts, and what's your total load in that area, do you know? Your total 200 plus kilowatt customer load, how big of a bucket are you drawing from to use your metaphor?
Yeah, I'm trying to do that math in my head. The system peak overall is, yeah. So at 3,000. So that group, yeah. Well, but let me answer your question this way, a little bit more of an approximate answer. We think about demand response penetration rates as being somewhere between 7 and 10%, depending on the program structure, as an ultimate upper bound for what we can deliver. And that's including customers kind of outside the specific range of 200 kilowatts and up. It's much easier, as you can see from this conversation right here, it's much easier to access the total system peak and think about it as a ratio that way than in the smaller there. So this right here is a little bit of fast forwarding to how we do what we do. What you see in the blue line at the top, that is an estimate of what this customer would use on a typical day. The green line is actually their performance during the demand response event. They're able to see this in real time. We're able to see this in real time to help them actually hit their numbers and deliver that reduction to the grid. And so that's really that pattern right there of that jagged drop off during the demand response event. That's the classic demand response shape.
So I'm kind of wondering about the mechanics on the customers and
Yep.
Idaho Power paying for that difference. What are they, is Idaho Power going to pay the customer to participate in the program? How does that all work?
Yeah, so the question is, how does it work economically? What's in it for the customers and how do the dollars flow? So the answer is that Idaho Power is paying Internoc to provide a firm resource just as they would pay a power plant or any other type of supply under a contract structure. We're then turning around and providing payment to all the customers that are in the portfolio. One of the things that we're able to do, however, that is value added for both parties is that we're able to make commitments to Idaho Power so that there are penalties, if we don't deliver what we're supposed to. At the same time, we're able to give some flexibility to individual customers when they need it, if something unusual is going on in the facility on that given day. Okay, so that's how the dollars flow. And did that answer your question?
Yeah, it does. I guess it leads to another one. I'm wondering about the blue line.
Mm-hmm.
How do you establish that?
Yep. So we use a rolling baseline on an hour-by-hour basis, looking at recent business days. Okay.
You have a typical, whatever their typical load profile.
Exactly.
Is that part of a contract with them where they agree that, okay, this is our typical load?
Yeah, establishing the baseline is actually, so we've established the baseline with Idaho Power, because that's terribly important in any demand response program, because the very nature of demand response is that you're measuring something that didn't happen. So you have to measure, you have to estimate what they would have used. One of the things about demand response, I think, which is similar to the power industry overall, is that on the surface, it's simple. You walk over, you flip the light, flip the switch, and the light comes on. Great, wonderful. As soon as you go onto the other side of that switch, it immediately becomes complicated from an engineering perspective, from a physics perspective, from a regulatory perspective, from an economics perspective. It's kind of similar with demand response. The idea is very simple, it's very elegant. At times of peak demand, we're going to coordinate hundreds of sites reducing their consumption of power temporarily so that we balance supply and demand. Pretty straightforward. Everything after that point starts to get complicated. That's just the nature of actually doing it. Does that answer your question as well?
Yeah, better idea for sure.
Okay, so these are some of the charts that we were able to provide to Idaho Power during the event itself. The folks in their network operations center that run their grid can actually see what we're delivering to them in real time. So it looks like a power plant to them. They can see, so here you see at the bottom, current performance is 103%, entire event performance is running at just over 108%. They need to see it and feel it for them as a resource, just like any other resource, or else it's not going to fit into how they think about the world.
Question on that.
Sure.
Is that based upon your guys' equipment or on the interval meter that Idaho Power has?
I think in this case, it's going to be fed back from, because it's in real time, it's going to come from us. So we're monitoring in real time. We're taking out of and here's the architecture, out of the Idaho Power meter, we're taking a KYZ pulse, and then typically over LAN or wireless if we need to, we're sending that back to our network operations center. Now here in Idaho, we've got a lot of meters that are on poles, okay? So that's going to require us to, in many cases, use wireless technology. So we're collecting that back at our network operations center in real time. We're using that for performance coaching to support individual facilities. We're also aggregating that into what you see here and giving that back to Idaho Power. Okay. Well, we've definitely begun the presentation because the questions are just going back and forth, which is great. So with all of that as prologue, some topics to talk about. Demand response in ENERNOC, our demand response program in Idaho, and lastly, given the group that we have here today, we want to talk about energy efficiency and how you can think about demand response as fitting into energy efficiency. So. And please, as you have, keep jumping in with questions along the way. The group seems to be really knowledgeable about demand response, but let's just start with the definition so that folks are all on the same page. What is demand response? It's exactly what it looks like. It's the reduction of demand on the at the facility side in response to a signal from outside of the facility itself. And that's an important distinction because a lot of facilities track their own peak. They understand that they have a demand charge and they want to minimize that. The difference between that, peak shaving, and demand response is you're reacting to a signal about what's going on the grid overall. That's what's different. Now, in that sense, that makes demand response really the very first application of the smart grid because that's what it is. It's the coordination of the supply side and the demand side to make it work more efficiently. And in that sense, there's no question that demand response is the first and most effective application of the smart grid. Why is it important and why does it make sense? And Billie alluded to this. It comes back to actually some pretty basic physics. We can't store electricity. If someone's got a way to do that, that's great. If they come up with some of that in the labs that are here, that's fantastic. But right now we can't do it. The best way to store electricity is to pump it uphill at night and then run it back through a turbine during the day when the power is more expensive. You got a lot of losses doing that, and you don't have a lot of places where you can do that in any really large volume. So the bottom line is that for most of the grid, the power that is coming out of that light bulb was generated instantaneously in real time somewhere in the region. Okay, what's the drawback of that? The drawback of that is what you see here. It's very, very rare that demand on the grid goes over 90% of peak. In fact, it only happens 1% of the year. It only happens 80 hours a year. And so we have to build all of this infrastructure and invest all of this money, but we only use it, all of it that is, about 80 hours a year, if that. So clearly, that's expensive. That's like building stadiums for the Olympics, having the Olympics, close them up, go away, and you never use them again. Not the best approach. And that's why demand response fundamentally makes sense. It arises out of the basic nature of how the grid works. So, okay, what are the benefits then? Revenue, we've talked a little bit about that, and we'll touch upon it more, I'm sure, as we go through some of the details of the presentation. Community. These events are called when the grid is at its maximum. And so bringing the community in to understand how that works and how that operates is very important and very helpful for helping people to understand what role their own usage plays in the workings of the grid overall. So clearly a benefit in that way. Demand response in the form that we're doing it here in Idaho is about managing peaks. And Billie really hit the nail on the head. We're looking to avoid building a peaking plant. Some of the programs across the country are a little bit different. They're designed to prevent blackouts in areas that are more grid constrained than Idaho. And in those situations, the community aspect takes on a bit of a different flavor to it. It's really, you're protecting your own business, your own home, and those of your neighbors from a very disruptive blackout. And so that's another aspect to it as well, in general with demand response. A little bit less so here in Idaho with the program we have. And lastly, with the environment. Demand response, the megawatt that you don't have to generate, the kilowatt, that's the cleanest one of all. Forestalling the construction of additional power plants has an inherent economic benefit. If nothing else, it gives renewables more time to get into the mix. And the more time we give them, the better they're going to do, because they're going to keep improving. In addition, the useful lifespan of any power plant is probably on the order of about 30 years. So once you've got it for a long time. In addition, as I mentioned before, some demand response programs are more about blackout avoidance than peak management. Blackouts are inherently disruptive and result in large releases of pollution when they take place. So avoiding those is also quite important. Okay, who is ENERNOC? So ENERNOC stands for Energy Network Operations Center. We're active across North America. The dark blue color are the regions in which we currently have demand response programs. We are headquartered in Boston. And as you can see, we have offices throughout the eastern seaboard as well as several offices in the West Coast and in the mountain region as well. We've grown quickly. We're a young company. We were founded back in 2002, but we've grown to over 2,700 megawatts under management, which would make us the 80th, roughly, largest utility in the United States if we were indeed a utility. Excuse me. We've got 2,000 demand response customers and just under 5,000 sites under management. And so from a relatively modest place back in 2005, we've really grown quite substantially, which I think speaks to the fact that people and regulators have recognized that this approach to load management makes a tremendous amount of sense. The NOC in ENERNOC stands for Network Operations Center. And that's exactly what we've built in Boston with a redundant facility out in San Francisco. Through the Network Operations Center, we track the power consumption in all of our facilities in real time. And that enables us to make sure they're ready to perform in an event and ensure that they, in fact, do perform in an event when those are called. The heart of that is PowerTrack. It's a proprietary platform that we've invested over $15 million in. And as Billy mentioned, when Idaho Power first thought about doing these programs, one of the things that they grappled with was there's a certain amount of infrastructure that you have to have in order to execute these programs well. And the incredible diversity of loads that are in this type of program is fundamentally different from, say, the irrigation program or an AC cycling program. The technology to support all of those different types of loads and measure their consumption in real time is what enables us to work with a wide variety. So what does it do? It notifies customers of events. It automatically does the curtailment for many of our customers who want that feature. And it does measurement and verification afterwards. So we're able to provide the data that Idaho Power needs to feel comfortable that they're getting exactly the load reduction that they have to have on their system.
Did I just hear you allude to the fact that some customers would manually go shut off equipment?
Yep, that's right. So, and it depends on the type of operation that they have. So an industrial environment where you have individual machine operators on heavy equipment, it's probably not the safest or even the best approach to automatically go and do that. Now, surprisingly, there are some industrial applications in specific programs where we do it automatically. For example, in the Mid-Atlantic region, we have worked with a very large arc furnace, which is about 30 megawatts, and we automatically turn that on and off. Okay, but generally speaking, a lot of operations it's just as effective to do it manually as automatically.
I would think a lot cheaper. I mean, I was just picturing in my mind. I was going to ask who goes out and installs this equipment. I'm just imagining all these switches everywhere, and it just seems like a nightmare.
Yeah, and so how we go about doing that depends on the application and what the need is. Oftentimes we'll go into an existing building management system and we'll write a script and then trigger the script. And so the building management system can go and do that. But we'll talk about that in design for demand response too, which is it's extremely important that some of that design is there to begin with to make that easier.
Is that negotiated between the end user and Internoc then?
Which aspect?
What you turn off.
Absolutely, absolutely. It's extremely important that people are comfortable with the plan. We're going to talk about the specifics of the program here in Idaho, but this is a program that can be called 10, 15 plus times per summer. It's got to be repeatable. It's got to be something that they're comfortable with, or else it's not going to be sustainable load over time. And our business is built on looking and being as reliable as a power plant to utilities and grid operators. And so having a plan where the customer isn't comfortable with it, they're simply not going to do it after a period of time and say, listen, this is too disruptive, we have to bow out. Okay, so it's the Idaho businesses that actually support this and actually deliver the load. Our role is to, as I mentioned before, is to aggregate all of these together and deliver to Idaho Power a single number that is as reliable and is as repeatable as having a power plant available to them. And we'll get that from a very diverse types of customers. Here are some of the things that we do. This reminds me of the New York Times, where it's like, what are you thinking about the economy now? And they have like anxious and nervous, all kind of streaming across the page. Let me point out some of the words that are more important on this page to me. Penalty-free participation is critical. I mentioned this before when we were talking about economics. In order for these programs to be valuable to Idaho Power, they have to have teeth. And if they don't have teeth, it just makes it harder for a utility to want to do them. On the other hand, while commercial, industrial, and institutional customers want to participate, taking on penalties outside their core business is typically not interesting to them. So our ability to stand in the middle and make an assurance one way while providing flexibility the other way is inherently valuable. In addition to that, end-to-end solution. For both the customers and Idaho Power, making this simple and easy is part of what makes us successful and has enabled us to grow quickly. To the folks at Simplot or any other large business, even any small business, they've got dozens of things that are high on their priority list to get done. And demand response is generally one of those things that doesn't fall in the I have to get it done today list. And our ability to lower the barriers to involvement is critical to actually getting people over the hump and getting them in there. But, yeah, we can talk all day about this. You know, a picture's worth 1,000 words. Maybe a quote is worth 500. We have probably at least 50 lumber yards. I would probably say closer to 100 that participate in demand response programs across the country. Great application for their business. So, this is where the rubber meets the road. These are the parameters of the Idaho Power Commercial Demand Response Program. Okay? It's structured with a combination of capacity payments and energy payments for the end users. And end users can expect to earn between $25,000 and $35,000 per year for participation in the program, depending on how many events are called. Okay? It runs for the months of June, July, and August, and it can be called during the program hours of 2 p.m. to 8 p.m. on weekdays. The advance notice is 2 hours. And in this structure right here is exactly what Billie was talking about when she said, you know, there's a bit of negotiation not only between ENERNOC and Idaho Power, but really between Idaho Power's customers and Idaho Power Dispatch. Because in a perfect world, Idaho Power Dispatch would have a resource that they could call with 10 minutes notice, 24 hours a day, you know, throughout the peak months, and that's it. That would make it, you know, that would give them maximum flexibility, maximum dispatchability. The problem with that is that very few customers could actually sign up for that. And so you have to sit down and do a really good assessment of what are the actual needs to provide value to the grid. At the same time, what is acceptable to as large a population as possible under the program structure so you can actually get a meaningful amount of load. And it's a little bit like a balloon. You can squeeze it in some different ways to make it actually work. This design, we're comfortable and confident, provides a lot of value to Idaho Power and is something that Idaho Power customers can actually do.
Said 25 to 30,000. How much power usage was that based on?
So payment. So I said $25,000 to $35,000 per year for each 1,000 kilowatts that are enrolled. Sorry, apologies if I didn't put that in there as well. Per 1,000, yeah.
And I also want to note that until we get approval, these are all proposed parameters and subject to change. This is what we have proposed and what we expect, you know, we would see, but they are proposed until we receive approval.
That's what I was wondering, because the tariff on the AC cool credit, it says that it's advertised as only about 15 minutes on, 15 minutes off, but the tariff is actually written where you guys could turn off for like 8 hours. Is that written this way?
It's written with these parameters as far as these are maximum number of events. This is worst case scenario. This is as bad as it can get, kind of thing. Okay. But yeah, we will use it only if it only calls for one event to prevent the peak that year. That's how it would be used.
Yeah. Yes.
It almost made me not get the AC cool credit.
I'm sorry. So there's a similarity there. There's a need to set up a program structure that has some maximums to it. And when you look at demand response programs across the country, there are different ways, I said, to structure those programs. And I'll give you a compare and contrast between this program and the New England program. The New England program has pretty much unfettered availability to the ISO there to call the events when they need them. However, the trigger is extremely rigid. Okay? They have a protocol that they go through on the way to blackout, and they can only call the program when they are 2 steps essentially short of blackout. So you only get 1 or 2 events per year. It's a different program than here. The purpose is different. The purpose is to avoid blackouts, whereas this is to manage the peak. So how the structure here is that the trigger for dispatch is more liberal, but there are some structures around, you know, duration of events, number of events, things like that.
I have a question on that.
Sure.
You have 5-minute interval metering. What are you metering there? Is that an individual customer?
Yes. So we're using that to construct the baseline and understand how much power they've dropped.
And because it's in, oh, excuse me, go ahead.
On your interval metering, is there equipment on the inside of the company that you sell to these customers that give them the opportunity to see which part of their load is or more interruptible than others?
So are you talking about sub-metering?
Yeah.
Okay.
Lighting, HVAC or hot water.
Yeah, so we develop a curtailment plan with them so they know exactly what they're going to turn off when the event takes place, okay? Now, we typically meter the entire facility, okay? And we typically don't sub-meter just those loads. We typically meter the whole facility. It's really much more straightforward to do it that way. It's much more cost effective. There are some instances where it does make sense to do sub-metering, but it's not typical in that way. Yeah. You had a question?
Oh, comment. The 5-minute metering would be then to determine, because the incentive is based upon actual kilowatt hour reduction and demand reduction. So between the two,
Yep.
if I read that correctly.
Yep, it's based upon between.
That's why you meter that drop.
Absolutely.
So you can get the profit.
Absolutely. And if you look at the evolution of demand response and the interruptible rates that came before it, one of the things that has enabled the demand response industry to arise in the last 10 years is really the advent of accurate, fairly inexpensive metering and communications technologies that enable us to take that information back to a centralized point in a way that is reliable and cost effective and quick. Okay. How do people do demand response? You know, how does it actually happen when the event gets called? And the answer is, it totally depends on the customer. It can be automatic, it can be manual. We've talked about that. I'm going the wrong way.
What about, one question, sorry, how do you respond to the criticism of backup generation for the fact that most of them are diesel generators?
Sure.
So I know some states have outlawed diesel generation for peak load.
Yep. No, it's a very important question. And the answer is, in large part, it depends upon the nature of the program. Okay, that's the first place I think that I would start the discussion, is if a program is designed for blackout avoidance, take for example the New England program is a good example, where the program is designed to be used literally as a line of last defense. It is their last resort before they get on the phone and call for voluntary reductions across the region. I think that under those situations, it makes a tremendous amount of sense to, in a controlled manner, run a small percentage of the backup generators, than have a very real risk of actually running them all because you have a blackout. Okay? In a program such as this one, where you're looking to manage a peak, that's a different discussion, and you need to look at what the environmental situation is in that region as to whether or not it makes sense. You know, is that region in attainment? Is that region not in attainment? Things like that. One thing that I think that is worth noting is that for programs where backup generation is eligible, you know, we certainly use backup generation, and we buy carbon offsets for all of it. You know, every bit of it.
Have you worked with DEQ at all to kind of get this in the door or make it easier, I guess?
I did want to say that that we have determined, at least for this year, that generators are not eligible for Idaho for this program.
Okay.
At least for this year. If we continue discussions later, maybe outside of the Treasure Valley or something that maybe makes sense at a later time. But this year, we've determined that they are not going to be part of this program.
Is that because of DEQ?
It's because it's one of those topics. It's politically charged. We don't really have all the applications worked out yet. We haven't been through. We haven't talked to DEQ. We haven't worked through those details, and because of our short time frame, we're just not addressing it yet.
Yeah.
Yeah.
So, and thank you for saying that, Billy. I took that as kind of a given. Yeah. So backup generators, they're not even on the table. This summer, we're not talking to anyone about backup generator participation in this program.
And whether we ultimately ever do, it remains to be seen. But as of now, we have no plans.
Yeah.
I think it's a worthwhile discussion with this DEQ because it's either natural gas there or here.
Well, most are natural gas.
Yeah, I was thinking hospitals and stuff.
Yeah, most of them. You're right. In some territories, where they are prohibited, it's very different. So take, for example, California. It's different if it's natural gas than if it's diesel. Yeah. Okay. So let's just some real-world examples of how people actually participate. Let's just take a look at it. So food production and storage, shutting down chillers is a very common measure. In a food production facility, you can shut down aerators, you can shut down barge cells, corn towers, and you kind of go on from there. You can, as you look through these examples, you can see that there's process equipment that can be curtailed in a whole manner of production facilities. There is HVAC and lighting load that can be curtailed in commercial office spaces and in other environments where it makes sense to go after it. And when you get down to it, you see that it's very situation specific. So you take waste and wastewater. The storage that they have in that facility enables you to basically time shift, okay, and have them participate in a demand response event. Great. Questions on these examples? We can certainly talk through any of them in deep detail.
My question's on your baseline, because I'm in the energy services business, and so I'm doing all this stuff already.
Yep.
Does that change my baseline?
Doing this stuff already.
Because then, so my project, a project that I do anyways is, if the civic center is empty, I'm gonna tell them to turn their air handlers off and their chillers off.
Yeah, so it's a great question. It's a great question. I mean, more broadly, the question is, what's the relationship between energy efficiency and demand response?
Well, no, I think they're both good, and I think they go hand in hand. But if, let's say, 1 year, this customer gets a demand response contract, and to do those things, I come in afterwards with an energy efficiency program that tells them to turn it off anyways.
That's right.
And does that adjust their baseline?
Yes, it does. Absolutely. And that's exactly what I mean by the relationship between demand response and energy efficiency. So and there are...
Go ahead. Contract isn't as good then, dollar-wise for them.
For the energy efficiency contract.
For the
either way.
Response,
either way. I mean, they're one and the same, right? Because a dollar is a dollar. More broadly, the question is, okay, what's the relationship between energy efficiency and demand response? And the relationship is that depending on the measure, they actually will eat into each other a little bit, and that's fine. Generally speaking, if an energy efficiency measure has a good payback, you should do it, and it may decrease your demand response capacity, you should do it. It's going to pay back in terms of kWh over the whole year, and we'll tell you that. Billie and I actually met a couple years ago when we were looking at participation with Albertsons across hundreds of stores, and the demand response measure that we identified was curtailing part of their lights. Well, Albertsons made the decision to turn off those lights permanently, okay? So they weren't able to participate in demand response at that time, but it was the right business decision for them. So you'll have some of those interactions, particularly in lighting. With VFDs, you may actually have a positive interaction in the sense that people might not be comfortable turning off a traditional motor for demand response, but they might be able to play with a VFD. And so that's an example of an area in which you might actually pick up some demand response capacity when you do an energy efficiency measure. Okay? But oftentimes, if you do an energy efficiency measure, you'll lose demand response capacity. It certainly doesn't mean that you shouldn't do it. You should do what's cost effective.
Does that mess up their contract with you?
Good question. So the question is, what is the impact on their contract with us? Okay? Our contracts are written to reflect the reality on the ground, which I think is the way a good contract should be written. And what it essentially says is, this is the starting number. And over the course of our contracts with our customers are typically 3 to 5 years. And over the course of that period, there's going to be changes. You're going to add new equipment. Your business conditions are going to change. You're going to do energy efficiency projects. So that number is going to evolve, and it should evolve. And when those changes take place, then we're going to change your number. And we're going to sit down and we're going to talk about it. We're going to make an adjustment. Yeah.
Have you guys documented any of this phenomenon of the increase in energy efficiency, just because the whole thing that people are aware that, oh, I'm not missing the fact that you shut my lights off every day, so I'm just going to leave them off, you know.
Sure. Have we documented in a?
Did you document any of that?
It's a good question. I think.
That's happened actually. We were just talking about this earlier today where we did another one of those lighting reductions, and in the process of demonstrating demand response, you know, some of the folks said, hey, well, this is actually quite nice. We can keep it like this, you know, all the time, and that does happen. And sometimes demand response leads to energy efficiency in the process of enablement for demand response. So, you know, grocery is just such a rich example. We can use it over and over again. Typically for grocery, what we do is put the lights into night setback mode, basically the stocking the shelves mode, which is, you know, 50% lighting, whatever the ratio is for the store. Many times we find in the process of enabling a facility for demand response that night setback mode was never properly commissioned. So they've got the lights going full force 24 hours a day. So when we go in and enable a site for demand response, we say, oh, your night setback mode isn't working. So we'll set it up and we'll make sure the scripts are working in the EMS systems. And from that point onward, they're properly commissioned and the lights are going on every night. So demand response, it's an interesting relationship, demand response and energy efficiency. Sometimes they cannibalize each other, sometimes they enhance each other. It can definitely go in all directions. But as you know, Michael clearly articulated, do it where the high return is. If it makes sense to do it. The whole pie is going to grow if we're thinking smartly about this. Right.
Yeah, and I think one of the things that's supported Enernoc's success is we're a bunch of people who believe that this is a good thing for the world and are passionate about energy, very passionate about energy, and most of us are also very passionate about the environment too. Someone from Enernoc's not going to tell a customer, hey, you know, don't do that energy efficiency measure because it's going to cannibalize your demand response dollars. Like, if it's the right thing to do, you should do it. Okay, how does it work? How does an event actually work in 4 easy steps? The notification comes through. There's 2 hours of advance notice. 2 hours of advance notice is a really nice balance point between what the folks running the grid in Idaho need in order to manage their peak and what works for customers in terms of curtailing load. 2 hours it's a good middle spot. You know, certainly when you start to get down to 30 minutes, 10 minutes, then you start to cut into which customers can participate, but you don't have too much of that at 2 hours. So they execute their curtailment plan, which we've drawn up with them, which we have documented and distributed to them. And then in the third step, we monitor it. Now, they can monitor it too at PowerTrack, okay, because they have access to the web application as well. We are also monitoring it, and we'll proactively reach out to them and communicate to them if they're not hitting their number. And lastly, we restore. And when we restore, then we analyze the event, actually 12 ways till Tuesday, and share it with Idaho Power and with the customers so that we can learn and we can do better the next time around.
So what are the options for notification?
Sure. Email, pager, telephone, and the system records whether or not a confirmation has been received. And if a confirmation hasn't been received, we're pretty persistent in a very professional way. We keep coming, and eventually you'll get escalated to you know, out of the automatic system and into a person who will handle contacting the facility until we get a hold of somebody.
And how do you interface to the meters and establish that communication, what protocol to use? What are you doing there?
Now, I want to make sure I understand your question, and that is, how are we communicating between the meter and our network operations center about the, about the consumption? Yeah. And so, from a technical perspective, we're actually using an application that we developed ourselves called PowerTalk. So we're using a software protocol of our own design. I'm not sure if that answers your question.
Well, what media are you using for that communication channel?
Okay, so we're using whatever makes sense for the facility, and let me give you a couple of examples. We prefer to use LAN. Okay, it's cheap, it's very reliable, it works for the customers, it works for us, and we have successfully gotten on to private corporate networks with some very security conscious customers. So that's something that we do in every case that we possibly can. As I mentioned before, a lot of meters here in Idaho are out on poles, and so we're going to use wireless technology there. We have installed meters in very remote locations where we've had to do solar batteries to power the meter. We've had to use booster signals to get the wireless out. We have not yet failed to be able to meter a site from a technical perspective. So our batting average there is good.
Cellular technology?
Yes. Yep.
As Michael was saying, sometimes we use local wireless. So just we grab a pulse off the meter and we just send it local radio to a receiver at that customer.
And then go land.
Send land back there.
Just a licensed 900 megahertz or whatever radio.
Is
Yeah, that's better.
Yeah.
yeah.
We call them mod hoppers as the device. It's
Yep.
one of our favorites there.
Do I remember right in saying you said 200 kW? Is that the minimum demand response drop that you are wanting to see?
As we progress through the whole customer base over time, over the course of the 5 years, the minimum that we'll look at will be 200 kilowatts of total demand in the facility.
Okay.
Okay?
That's totally.
Yep. So,
In curtailing, how do you, I assume you've got some kind of estimate of what you can curtail per
yes,
customer.
absolutely.
And you've got all these customers. How do you prioritize that?
I'm not sure what you mean by prioritize.
Well, you're ultimately providing a source that can be scheduled for the
Yep.
dispatcher.
Yep.
And they call for so much energy.
Yep.
You're going to meet that request.
Yep.
And so you're going to start curtailing.
Sure.
And you've got this mix.
Yep.
So if
They
you have
tend
a-
not to. The answer to the question is generally fairly simple, and it's this: they tend not to call for part of it. They tend to call for all of it. So, and if we get to a situation, if Idaho Power says to us, we only want 25 of your 65, that's fine. But it's Billy's shaking your head. It's not going to happen, and I'll tell you why. It's because when they need it, they really need it, and they want the margin of safety. And again, if you think about 65 megawatts in the context of the Idaho peak power, several thousand megawatts of peak, you're still it's a peaking unit, which is great, but it's still part of a much larger picture. They're not going to want to call for just half of it.
You visualize it as a
stack.
step function where you're calling for everything, and then it comes up with an exponential. As it's got a time response for the system to respond.
For our load.
Yeah.
We've got the 2 hours. We notify our customers as soon as we receive notice from Idaho Power that they want the load, and then as we get into the event, what we're really looking for a perfect rectangle, right? We're looking to deliver 100% on minute 1 and 100%, on minute 180. And so as soon as we get into the event and people, if customers are not providing their full amount, that's when we shift right into performance coaching and reaching out to them and talking about what's going on.
So you actually, I assume then you're characterizing the response of that supply.
By characterizing the response, we have expectations for what we're going to get from each and every site. Absolutely.
But you're actually, I assume, measuring it and characterizing,
Yes.
mathematically characterizing.
Yes. We're measuring the aggregate as well as we're measuring each individual site. Yes. Okay. So some design for demand response. There are a number of important and valuable things that can be done up front to make a facility more amenable to demand response. And as with any other design aspect, once you don't have it coming out of the gate, it can be really expensive and difficult to put it in after the fact. So what are some of those elements? So first one, smart circuitry and lighting controls. Relamping and rewiring facilities so you've got an A-B configuration when before you have a block configuration is very expensive. It's not cost effective. We typically don't do it for a demand response measure. Billy's laughing. Why are you laughing? But if you have A-B actually within the fixture or a checkerboard pattern, then across a grocery store or a large space, then you can actually do something. Okay, so you kind of have that to begin with, or you don't. Kind of similarly with lighting controls. Leveraging an energy management system for HVAC, lighting, and refrigeration, it's a great demand response measure. If the building doesn't have those types of intelligent controls, it can be fairly difficult or even not cost effective to access the load and put it into a demand response program. Okay? So these are elements of building design that have an added, that really have a boost to what they can do for demand response. Conversely, if you're looking at doing an energy efficiency project, one of the things that it may make sense to look at for your payback is demand response participation, to get a little bit of a boost on your own ROI.
Is there an average, like you say there's a maximum demand? Is it really just a shot in the dark whether or not it's actually going to hit, or the maximum amount of hours of a demand response event? Do you usually, like, say you're doing an average calculation, is it right in the middle of that 20 to 80 hours, or?
Unfortunately, I'm not sure I understand the question.
I'm thinking of that slide back there that said all the all the criteria.
Yeah.
And I'm
sure.
thinking, so if I was to go to a customer and say, well, there's a demand response event, yeah, it's up to 60 hours. That's
Up to
what it
60
was.
hours.
So up to 60 hours, and say, okay, so we turn back your fans a little bit, we turn back your lighting a little bit.
Yeah.
Up to 60 hours, is that pretty much, would you just assume that, or would it say?
Yeah, so there's kind of maximums, and then what's some guidance, and we work really closely with Idaho Power to have guidance, so we don't think that this program is going to be called 10 hours a year. That's not what we coach customers to. It may be called 60 hours a year, and we talk about that eventuality, okay? But our guidance is that we expect it to be called somewhere in the middle. It's going to be called, a good expectation is around 30 to 40 hours per year. And I don't know, Billy, do you want to add anything to that?
At this point, it's all speculation. 60 hours is what we have because that's what we know would meet our needs under most circumstances. So whether that's likely, we don't think that's likely for sure.
Okay.
Yeah.
I'm kind of thinking, because when I'm doing energy calculations, and you were talking about bringing that in as a dollar amount to help with this measure, putting a dollar amount to those hours that the demand response is there, this particular BFD has a little bit more instead of it, so it's just kind of, I was wondering if there's an average hours that probably just
we should talk about, it really comes back to, it's not as much around the hours as it is around the KW, because most of the value is in the KW that could be curtailed. So if you're going to dial back that VFW from a 90% flow rate to an 80% flow rate, then you want to do a fan loss calculation on the reduction in KW consumption during that period of time. You want to take that KW number and talk to us about what the value of that is in the program.
Okay.
Does that make sense?
Yeah.
Okay.
So it's more about the KW rather than...
It's much more about the KW than the KWH. Yeah.
Okay, that
The
makes
significant, more of the value is there.
Thanks.
Yeah. Okay. We're going to finish up on a related but slightly separate topic, just energy efficiency in general. We've talked throughout the discussion today about what the relationship is between the two of them. And, and this kind of talks about some of the ways in which they actually go together really well. In terms of individual measures, sometimes they're complementary, sometimes they cannibalize each other. That's fine. As we said before, you should always do what's cost effective. But at an organizational and technological level, they're very, very helpful to one another, okay? So if you think about it from an awareness perspective, as soon as you start thinking more about energy and just get smarter about energy consumption, the people in that facility are going to be more attuned to what they may see on the other side. So you start in DR, you get it more on energy efficiency. You start in energy efficiency, you kind of get it more. They are cousins, One of them is focused on saving energy throughout the entire year. One of them is focused on saving energy at the point of maximum value. And that's that's awareness. Technology, Mark gave a great example of just real-time energy information, which we provide for demand response, is a great tool for energy efficiency. This is something we hear all the time, is our customers go in and they're like, wow, We thought that in the middle of the night or on the weekends, our facility was down around 200 kilowatts. Our peak's around 1,600, and when we're doing operations during the day, we're at like 1,000. Well, we're actually at like 600 on Saturday at 4 o'clock in the afternoon. Why are we at 600 kilowatts? I mean, what is going on? So people go in and they find phantom loads that they don't think are supposed to be there, and they go and attack them. It's just right there, the information itself is valuable. And then, on the revenue side, there's a pretty direct linkage too. Demand response is often the easiest way to begin participating in these programs, and just taking energy for energy management's sake overall. And that cash flow stream, and some of our customers will take, and rather than putting it into kind of the general ledger, they'll get it reserved for the facilities department to do other things that they want to do. There's a question.
Yeah. Do you allow the customer to utilize your program outside of the June to September timeframe, or is it basically like, can they use what your system, or your energy track, or whatever you call it? Can they use that outside of the dispatch events, or is it?
They can use PowerTrack 24 hours a day, 365 days a year, as long as they don't call it energy track. As long as they don't call it energy track. If they call it energy track, we turn it off. Okay, so that's kind of the overall relationship between demand response and energy efficiency. This is not a big surprise. This whole area is receiving a tremendous amount of attention now, and more so than it has ever received before. ENERNOC is really actively thinking about this. You take telecom, which is measured in an extraordinarily detailed way, but in fact is a much smaller expenditure for businesses than energy is. So it's kind of, this is still, I've known this fact for quite a while. I still find this incredibly interesting.
This is just the building sector, right?
This is commercial and industrial companies overall.
Okay.
So what they're spending, and you look at the degree of attention that's being put into one expense versus the other. Ooh, I'm going the wrong way. Hold on, bear with me. Okay, so outside of demand response, ENERNOC has a service called monitoring-based commissioning. And the idea behind monitoring-based commissioning is essentially this. Monitoring-based commissioning is about improving the efficiency of the operation in real time as you operate it. It's like your car telling you that your fuel economy is down because the tire pressure in the left front tire is bad. What does that analogy mean for a building? Well, over time, with traditional consumption, with traditional monitoring, what you see is you get this. Now, this may be a big project to recommission the building. You come in and you do a study. But you get drift, just like your car gets out of tune in the 15,000 mile interval between when you take it into the shop. With continuous monitoring, you don't get that drift. You stay where you are. So what does that mean? What is it that we're actually doing? From a technical perspective, here's what it is. We're going into large facilities that have sophisticated building management systems, and we're pulling out the data. And when I say we're pulling out the data, I mean we're pulling out a lot of data. We're taking pretty much everything, and we're taking it at 5-minute intervals. So the air handler unit set points, the lighting schedules, all of it. We're taking it and we're putting it through a series of proprietary filters that kick out things that aren't working properly. And they're not general, they're not vague, they're extraordinarily specific, okay? So we tell them things like, air handler 42 on the 6th floor isn't operating efficiently and is off schedule, it needs to be maintained. We tell them things like, you should go and install fans on the intake unit in the basement. It's a good example of one of the things that that we're doing is with this type of customer. take a look at the quote, is they're finding improvements just by using PowerTrack and finding things that they can do in their facility.
So you charge them more, that's included as part of the program?
Yeah, so this quote right here, this is a traditional demand response customer, okay? They get PowerTrack for free. So that is very straightforward, right? So this is just looking in at a top level and seeing their energy consumption. The types of things that they're finding are like what I mentioned before, where they say, wow, we thought that our demand was only going to be 200 kilowatts at 3 o'clock in the morning when everyone's gone home, but it's actually 500 kilowatts. That's the type of measures we're talking about here. Up here, okay, we're talking about a continuous monitoring solution. That's appropriate for, for large high-rise buildings, for university environments, for hospital environments where you have a sophisticated BMS. That is a different service. It's called monitoring-based commissioning. Yep.
So your system kind of piggybacks onto the energy management system.
For monitoring-based commissioning, definitely. Definitely. We're not controlling. We're not reaching into the BMS. We're taking information out of it and using that to develop a very deep understanding of what's going on in the facility. That's it. Thank you very much for your time, and keep the questions coming.
Let's talk about security, I guess, because it sounds like you have access to some pretty good information.
Sure. Well, it depends on how you think about it. How valuable is it to understand the energy consumption of a large investment bank in New York? I mean, we know how much power they're using.
A manufacturing facility and the scheduling of resources.
Sure. Again, we see the energy consumption. We're not necessarily seeing units produced and things like that. But yes, absolutely. I mean, there's a deep contractual relationship.
Correlation to manufacturing cost.
Yep, absolutely. Nope, that's right. So yeah, so you've got, there's a legal agreement. It covers confidentiality for sure. Yes. Yep. And again, just in terms of our demand response service, the virtual private network protocols and security protocols that we use have been sufficient for us to satisfy customers to do LAN access with us who are very, very sensitive, including some of the largest, for example, telecommunications companies in the United States. For example, one of them, we manage several hundred facilities of theirs for demand response. And getting LAN access for them, which we ultimately did achieve, took about 12 meetings with 4 different organizations within the company, but we did it. They were ultimately satisfied by our security protocols.
Questions for Michael or for Billie Joe? You had a lot of questions during the...
Oregon, are they going to be coming on? I know their PUC takes longer.
Well, yeah, and a lot of it's the time frame for this year. Obviously, it's sort of condensed anyway, but we definitely will be going into Oregon.
What are your main client targets? Are they just the utilities, or in some cases would they be municipalities, or where cities are developing or have existing municipal utility systems, or what's the scope of your?
So in terms of who do we work with at ENERNOC? Okay, so we work with the deregulated system operators. So we work with all of those, and if we're not actively working with them, we're talking with them about the development of demand response programs. And we will generally work with utilities. Any of the several hundred largest utilities in the United States are kind of good, appropriate customers for ENERNOC.
We work with the little guys too. We have a couple of municipalities.
That's true. Thank you, Mark. I appreciate that. And so here's a good example. Utilities of any size will sometimes, they'll just have constraints, and they may have localized constraints just because of the layout of their distribution system. They may only need 20 megawatts, 15 megawatts, but if they don't have it, they face some difficult situations around, we don't have either the capital budget or we don't have the physical space to get in there and do the upgrade for that station right now. So we need to buy 5 years to figure this situation out while we don't have blackouts in this quarter of the city. That's the type of situation where we'll go in and work with that type of utility. It's fine. So the size of it, we're very happy to work with smaller customers.
We have a contract with the Independent System Operator of New England, a 30 gigawatt system, and we also have a contract with Burlington Electric. It's like a 50 megawatt system, and it's just because of exactly what Michael was talking about. There's local constraints that they have to worry about, and that's within that's actually the overlapping territory. So Burlington is within ISO.
I wonder if you might have, a situation with, say, a cruise ship that might encounter constraints, or a large naval, aircraft carrier. Or, you probably could think
That'd
of
be
all
fun.
kinds of scenarios.
We actually have the QEW in the contract. Remember that? But it's
What's a QEW?
Queen Elizabeth.
Yeah.
Oh, the
The
QE.
boat. Yeah.
I thought it was the QE2.
Oh yeah, the QE2. Sorry, QE2. I was thinking of
okay.
the highway in Ontario. Yeah, the Queen Elizabeth is like permanently docked. It's not exactly what you're talking about, but it's an interesting idea.
Okay, because there are also a whole fleet of the MARAD, or the Maritime Administration ships that are utilizing tremendous amounts of
And
energy.
we actually do have another maritime. We have a maritime academy boat that, when it's in dock, is the customer of ours. But these are still for grid constraints, not for the ships themselves. Is that what you're talking about? Like on the boats?
Well, some are connected to the grid, others aren't. Anyway, that's cool.
Yeah. That's interesting. Yeah,
Get into
we do.
all that. I'm sure the DOE, there are all kinds of applications. And you mentioned Albertson, so I assume that you're also working with large, department store chains and potential future.
So how about one more question?
Sure.
For Billie, obviously you've gone through and analyzed, what the potential is within your service area. To what degree have you actually solicited those customers as far as their interest in the program?
Well, we are kind of in a balancing act because we have not received PUC approval, and so we have to be careful that we're not actually implementing the program based on the assumption that, we're just, we want to make sure that we honor that process. But at the same time, they do understand, and we've had conversations regarding the time constraints that we're under. So what we've done is actively informed our customers. And Internoc's been really good about getting people here on the ground to be out talking to all the customers that are immediately, the largest customers, the biggest potential that we see immediately. They've been out talking to them, informing them this is coming. We don't know when, but when it does, would you like to be ready to participate? So we're doing all the legwork that we can without actually signing. They can't sign anything because it's not technically a program until it's approved. They can't enable sites. We can't do any implementation until we actually have that order. So what we've done now is made a concerted effort to educate our customers, get them on board with the idea so that once we get approval that we can just run with it, enable sites. We'll be in a real crunch for time when that happens because right now we're a couple weeks till June 1, and their typical, I think it's 4 to 6 weeks is their typical lead time to enable sites. So in the answer to the question is we're talking to customers and that's the extent of it at this point.
Good questions, good dialogue tonight. Thank you, Michael, for being
Thank
here.
you
Thank you,
very
Billy,
much.
very much. I learned some good things tonight about demand response, and I hope we can talk about this in the future a bit more, maybe with your customers, and get an idea of how it's working. Thank you all for coming on behalf of Better Bricks Education and Training, and of course Northwestern Energy out of Montana, and Idaho Power here, and Integrated Design Labs in Bozeman, and University of Idaho, if I can spit that out. Thanks for being here. I want to say one thing about a really neat opportunity we have coming up. This is the last of our spring series. This was our last session. We'll have another series beginning this fall. But in between now and then, we have a couple things coming up, a couple events, and what really stands out to me right now, we have an opportunity. We are bringing, Better Bricks is going to support bringing Guy Battle here through the Integrated Design Labs in June 26th. And if you don't know who that is, he's actually an engineer, but he does engineer and architecture. He's out of the United Kingdom. I heard him speak at Green Build a few years ago when it was in Portland, and it was the first time I ever really heard that the concept of real net zero and going beyond net zero, where he was challenging us to build buildings that actually produced energy for the community. And he has some really great real-world examples on integrated design and net zero. So he'll be here, and we'll get you more details June 26th, though, for a luncheon. With that, thank you all for participating in the series. Thank you again, Michael. Thank you, Billie, for sharing this program. And that's it.